Alright, hello. So, today we're going to be I'm going to be showing you how to calculate pi on your own. Now, all you're going to need for this is a calculator. So, first I'm going to show you some stuff. So, if you don't know already, pi is the ratio between a circle's circumference and its diameter. The circumference is the distance around it, like here. And the diameter is the distance from one side to the other while passing through the center. So it's the longest part of the middle. Now, say this diameter was 1, then the circumference over here would be pi, which is like this. Now, pi, if you don't know already, is about 3.1415926. I could go on and on. You can go on for like millions of digits. So, now already this so far is pretty accurate. This is like the 100,000th place. It's pretty cool. So, when I was younger, I never used to knew pi and like what it was and memorized a bunch of digits, but I never knew how like people would calculate it. And I found a really easy way that I'm pretty sure the Greeks figured out about 2,000 years ago. Is what you do is you find first you take a regular polygon, which is like a square. Oh, that's not a square, sorry. But what you do is you add a bunch of sides to it. So it's first you can start off with maybe an octagon. This is a bad drawing, but just imagine that's like an octagon. And then what you do is you find this distance here, which is similar to the radius. It's called the apotheum. And you'd find the ratio of that to the perimeter. Now, as you keep adding more sides, it keeps getting closer and closer to a circle until you get something like this, which kind of looks like a circle. Then you can get even more sides and more sides till it ends up looking like this. Now, you might think this is a circle, but technically, this could be classified as a regular polygon with thousands of sides because of the pixels are really lines instead of pixels are not curved, they're squares, so they're lined like that. So what we do is, first thing, let's zoom in on, let's do one with 360 sides, since there's 360 degrees in a circle. So imagine this is the side, mark it with S. This is the apotheum, mark it with an A. This is the center, and then we'll finish it off because it's like a triangle. So you can find the apotheum using simple formula. Well, not really. So since we formed a triangle here, now remember, in reality it would be something like this. We're just not including that part of the shape. If we say the side is 1, so side equals 1, and then since there's 360 sides, this is 1 degree, then we can use trigonometry to find this A, which in this case, since there's 1, it's sine, because it's opposite over adjacent, so it would be 1 divided by sine of 1. Now we just do that in your calculator. And we get 57.298 blah blah blah. So that's this number. So we're actually going to drag it over there. Now I'm going to keep the rest of the digits. I'm not going to write them out here in my calculator so I can use them for later. So now what you do is, so since this is 1, right? And there's 360 sides, that's 360 is the perimeter. Then what you do is you take 360 and divide it by this 57 number, which I have stored. And then you get 6.28 And remember, this is the radius. We need to find the diameter. So you divide by 2, and it's ... I forgot the 2.28.28 divided by 2, and we get 3.14. I can't write this. 3.1414. ... Okay, I'm running out of space. I'll drag this over here. Now, as remember, pi up here, I'll move it up here, is 3.1415. So we got to the 100th place with accuracy. So that's pretty good accuracy. For right now, we're only a 10th of a 100th off. But say we wanted to go even more accurate, what we would do, we would just increase the amount of sides. So instead of this being 1, all we have to do is decrease the angle from 1 to 0.1, since we're going to add 10 times the amount of sides. So instead of 360 sides, it would be 3,600 sides. So instead of 1 divided by sine 1, we do 1 divided by sine 0.1. So let's do that again in the calculator. Second. Sine 0.1. 1 divided by sine 0.1. And then we get 572.95 ... And then again, now we do 3,600 divided by that. Divided by this number, so it would be 3,600. Now we take that all and divide by 2. And this time, we get 3.141591 ... Now if we bring it up to here, you'll realize it's even more close. Like, we're down to like 6 digits that are accurate before it veers off. Now all we need to do is just keep increasing the amount of digits. Now I'm starting to run out of space on my calculator, so I can't go much further. But if you had just like a computer or something with like a longer calculator, then instead of 3,600 sides, you could do 36,000, 36 million, 36 billion. And just keep doing that exact same formula and keep getting closer and closer to pi. And then eventually, you could go to 1 million digits doing this. So that was pretty cool.